Okay, so let's make this interesting for you guys.
We crash it. We don't care about the damage. We care about people. Our testing exceeds the government standards. Ford has more 5-star rated vehicles than any other car manufacturer. We go that extra mile to make sure our cars are safe. I'm proud of that. We crash it. We don't care about the damage. We care about people.
All right, they don't care about the damage. They care about the people. But look at the damage, guys. This car is totaled. This car is totaled at 40 miles per hour. You're done with this car at 40 miles per hour. This is an average texting speed. This is a fast parking lot speed. You simply do not see the building coming. And then you're done with this car. You cannot be expected to pay attention 100% of the time, and a small, simple mistake just costs you a car under the circumstances. Why do they make these cars so crushable? Why not go back to the good old times and then make these cars virtually indestructible and put the safety on the inside?
Because the car, part of the advantage of a car crumpling like that is it absorbs much of the impact forces, and they're not translated then into the person. As the front of the car crumples, it slows the person down more gradually than if it came to an abrupt stop, causing them to slam forward.
Okay, so here's what I'm hearing. I'll give you 5 points on that one. You're saying that the reason why this happens is because of safety, right? All right, so they make these cars crushable because of your safety. What I'm saying is, hey, I get that. I get that. Why not put the safety on the inside? Make the outside indestructible. Put the safety on the inside. All right, so which means that you can text and drive if you want to, so it's not a big deal if you're late to work or whatever. If there's a red light stop sign, just go through it. So you're gonna get hit from every which direction. Who cares? Like, get a pillow if you don't like if you don't want to watch it. If it's gonna make you feel safer, just put the pillow in front of you. Put the safety on the inside. That's what I'm getting at. Why not do it that way? Oof. All right, the reason why they make these cars crushable is because, obviously, they are trying to, it's because of safety. You guys kind of guessed that correctly. So it's because of safety.
Also makes you buy another car so they get more money.
It increases the time of the impact.
It increases the time of the impact.
Decreasing momentum.
Increasing momentum. All right, both of you guys, I'm going to give you guys 5 points for those comments. All right, moving forward. Its primary reason is safety. Okay, because acceleration can kill. So the question is, how? As an example, prolonged exposure to like 7 to 12 G's of acceleration up to a few minutes can kill. G is the same as your own body weight. So being exposed to 7 G's, it's going to feel like 7 times your own body weight. Being exposed to 12 G's, it's going to feel like 12 times your own body weight. So prolonged exposure means anything up to a few minutes can kill. So the question is, how does acceleration kill? Most of you guys naively thinking that if you're exposed to about 7 to 12 G's, it's going to crush you to death. The reality of it is it's not, guys. The way you will die is going to be one of the most pleasant life experiences you will ever have. In fact, if you're not careful, it could be addictive. You're going to feel peaceful. You're going to have an out-of-body experience. And if I keep you there long enough, it can actually kill you. How do I know so much about it? The reason is because pilots in training on a regular basis, they would be exposed to 7 to 12 Gs. I'm talking about fighter jet pilots.
Here at the Via Corporation Flight Simulation Lab in Warminster, Pennsylvania, Dr. James Winnery and other researchers are using a centrifuge to reproduce high-speed flight conditions.
The video stuck.
Okay, is video stuck?
The G-forces have on the human.
Yeah, it was just like a picture, but the
video's really
sound was still going.
All right, so let's keep moving. And indeed, you may have to go back to the recording of it.
Brain.
Because it's playing just fine on this end.
So you're going to have to really strain now, Rob. He's really going to maneuver.
This video of Winnery, recorded in 1985, dramatically illustrates what happens when pilots experience a blackout episode.
First thing that happens is blood flow begins to be reduced to the head. So you begin to develop a tunnel vision.
All right, so notice that what happens is he starts to pass out.
The next
His eyes are open and kind of looks dead at this
thing
point.
that we
And he's done
see is
at
loss
this
of
moment.
motor control, loss of sensory input,
And then this is when they will stop the
complete
experiment.
loss of consciousness.
He's out.
Dramatically illustrates.
So he's exposed to 7 Gs. This guy's a medical doctor.
There are actually a few videos that are more modern, and they actually see the guys actually trying to breathe.
Yeah, you will see the.
Yeah, they almost passed out. A couple did, because it was like 6 people, and like 3 of them passed out. The other 3 almost did, but didn't.
Good point. You give yourself 5 points. All right, so this guy's a medical doctor. He wants to experience what these pilots go through, and then he's making these internal observations. So one of the things that he's noticing is
experience a blackout episode.
now notice that he starts to lose consciousness. He starts to black out.
Is blood flow begins to be reduced to the head. So you begin to develop a tunnel vision.
So he's got he passed that point at this guy is out. All right, so the question is this:
to the head.
Why did he pass out at 7 Gs. What's your explanation for it?
To reduce the blood flow to the brain.
All right, how does the blood flow to the brain get reduced? What
The
reduced the blood?
pressure.
Our bodies are
it's
used to
going-
functioning normally at regular levels of gravity. That's why our heart can pump blood to certain places, but when you add extra force, you can't pump the blood up anymore. It can't get up to the brain, so it drops down lower.
Okay, I'm gonna give you guys 5 points for that one. Why is it that the circulation to his brain end up getting reduced from a physics perspective? Let's take a look at it. It's related to something that you experience on a regular basis. Case in point, you're inside a car, and then the car accelerates in the forward direction. What happens to your body? You feel a push in the opposite direction of the acceleration, right? Into the seat. You feel a push in the opposite. Car accelerates forward, you feel a push in the back. And then when you put the brakes on, now you feel a push in the forward direction. When the car is slowing down, you end up feeling a push in the forward direction, in the opposite direction of the acceleration of the vehicle. All right. So do you guys notice that your body moves inside the car, always in the opposite direction of the acceleration of the car? Car speeds up in the forward direction, body moves backward. Car is slowing down, your body moves forward when the acceleration is backward. So the unstrapped objects inside vehicles will always move in the opposite direction of the acceleration of the vehicle. Unstrapped objects, anything and everything inside the car will move in the opposite direction of the acceleration of the car. Now, those of you guys who are religious, okay, notice that Jesus is having a hard time keeping up with this cross. All right, acceleration could be a religious experience. Case in point, what's the difference between a Ford Tempo and a BMW? Price tag, right? Ford Tempo can go from 0 to 60. So could a BMW, except in the case of Ford Tempo, it's going to go from 0 to 60 within about 3 minutes down a hill, and BMW is going to be less than 4 seconds. All right, so every time you're paying for a car, you're paying for its acceleration. All right, pick out the best answer, and then put your answer in the chat. All right, so the best answer is going to be, this is going to be B, right? So those of you guys who pick B, give yourself 2 points. So unstrapped objects will move in the opposite direction of the acceleration, so they will move. If the car is speeding up, they will move backwards. Okay, now we got a slight problem. Okay, let's explain why the pilot in the first place ended up passing out. Imagine that I'm driving my souped-up Ford Tempo in the forward direction, and imagine that this Ford Tempo is capable of accelerating at 7 Gs. All right, so I accelerate in the forward direction, what happens to my body? My body's gonna move in the opposite direction of the acceleration at 7 Gs, right? So what happens to the blood in my body? It's also gonna move in the opposite direction of the acceleration within my body. So what happens to the blood in my brain? It's gonna start to get pushed towards the back of my head, towards the back of my brain. So the blood is gonna start to pull towards the back of my brain. So what happens to the frontal lobes? All right, so blood is gonna get drained away from the frontal portion of the brain. So the lack of blood, lack of oxygen, you will have a blackout. If I keep you there long enough, I may end up killing you. So that's what happens. All right, except there's a slight problem. The problem is none of these pilots, none of them were speeding up. All of them were moving at a constant speed. They were all moving at 65 miles per hour. They were all moving in a circle, and all of them were exposed to 7 Gs of acceleration. So the question is, how do you induce acceleration at 7 Gs at a constant speed? How does that happen? All right, guys, how do we induce acceleration at constant speed?
The constant change in direction.
All right, so the speed is not changing, but the direction is changing, right? Let's focus on that. So how fast you speed up is acceleration, so it's how fast you slow down. But how about how fast changing direction? All right, I'm going to give you 5 points for the suggestion. So let's explode. All right, so take a look at the pendulum. When the car accelerates in the forward direction, what happens to the pendulum? It's going to move in the opposite direction of the acceleration of the vehicle. Boom. So the vehicle is accelerating, the pendulum moves backward. So when you put the brakes on, the pendulum moves forward when the car is slowing down. So it moves in the opposite direction of the acceleration. Okay. What do you suppose is going to happen to the pendulum if you're driving on a curve, on a circle? Notice that the pendulum moves away from the center of the circle. All right, given the fact that the objects accelerate, unstrapped objects accelerate inside vehicles in the opposite direction of the acceleration of the vehicle, that means that the acceleration has to be directed towards the center of the circle. All right, so this is otherwise known as centripetal acceleration or center-seeking acceleration. Now, the pilot or the medical doctor that you saw inside a centrifuge was sitting inside an upright centrifuge. An upright centrifuge is you're sitting with your back against the wall, so in the upright direction, out of this page, out of the screen that you're looking at. So notice that the acceleration is directed towards the center, which means that the blood was pulling away from the center towards the back of his head. All right, now we got the definition of acceleration. So it's not only how fast you speed up or slow down, it's also how fast you change direction. That's also acceleration. Okay, guys, once again, got the best answer. And then put the answer in the chat.
This is slightly off topic, but if you put a helium balloon in a car, it actually does the opposite and moves forward when you drive because of the air pressure pushing it.
Okay, okay, can you hold on to that topic until we get to fluid dynamics? Because that's a really good question. It's it's not quite off topic, but it's related to what we were discussing in a different sort of way. It's related to density, whatever that is, so we will discuss that. But I want you to give me a reminder on that. I'm going to give you 5 points of that one. It's related to this, but it's a little bit different. And I love that example. All right, so in this case, the best answer is, I'm looking at the answer, so it's moving at a constant speed, but it's moving in a circle. Is it accelerated? And the best answer is going to be, of course it is, because the direction of motion is changing. Okay, so those of you guys who picked this, give yourselves 2 points for that one. All right, plenty of you guys got that. All right, Okay, so the next thing I'm going to do is, let's catch on a little bit. Okay, so acceleration is how fast you speed up, slow down, or change direction. Okay, the proper definition is something we will come up with shortly. What's a G? G is the acceleration expressed in terms of your own body weight. So 7G is like 7 times your own body weight, 10G is 10 times your own body weight. So unstrapped objects inside an accelerating car will move in the opposite direction of the acceleration of the vehicle. Speeding up is acceleration because the unstrapped objects will move backwards inside the vehicles. Slowing down is acceleration because the unstrapped objects will move forward. Moving at a constant speed while changing direction is also acceleration because the objects will also move in the opposite direction of the acceleration. So if that's the case, what's the proper definition?
Change of velocity over time.
Okay, very good. It has to be, velocity is a combination of speed and direction, right? So speeding up is going to change velocity, slowing down is going to change velocity, changing direction is going to change velocity. So why not say how fast the velocity changes in time? So that's exactly what we will do. So give yourself 5 points. How fast the velocity changes in time. Okay, so for this one, I'm going to give you guys 5 points. Okay, so pick out the best answer. Okay, okay, so I'm looking at the chats right now. I'm seeing, all right, I see a lot of D's. I saw one C. Okay, so the best answer is, obviously, this is the definition of acceleration, right? How fast the velocity changes in time. So if the velocity of an object changes, it's always true that the object is accelerated. So D is the best answer. So I'm going to give you guys 5 points for this one. Okay, so you guys got that one right. Okay, so let's set up the mathematics for this one, mathematical modeling. Acceleration is how fast the velocity changes in time. So you go from initial to the final velocity within this time period while you're accelerating in the forward direction. All right, so the change in velocity over time, you go from initial to the final within that time period. So that's your acceleration, A is acceleration. All right, V, O, and V are initial to final velocities. Time is going to be your time. T is going to be your time. All right, so numerator is going to be in terms of meters per second. Denominator is going to be seconds. So this is going to be meters per second per second. That's the same as meters per second squared. So that becomes the unit that we got. All right, so that's the basic definition of acceleration. So that's how fast the velocity changes in time. How fast the velocity changes in time. Okay, so for safety reasons, we will express acceleration in terms of G's. Okay, 1G approximately 10 meters per second squared. I say approximately. How many of you guys know what the exact number is?
9.81.
Okay, it's not going 8081 either way. Give yourself 5 points for that one.